Okay, folks, we're going to give it just a few more minutes and then we'll get started. We're going to get rolling because we might need all of our time. Well, welcome everyone to the third and final part of Darlene on drugs. We are very excited to have Darlene with us yet again. And today we are actually covering what the testing is that actually happens at the Washington State Patrol Toxicology Labs. And as always, we know you're busy. We know that this is probably your lunch hour, so there's no need to take notes. There will be a handout provided. We're going to send a follow-up email, and you will automatically receive credit for the CLE if you filled out the registration survey that was sent to you, I believe, earlier this morning. Otherwise, we will provide you also with the activity ID if you need to report it yourself. If you look at this slide at the bottom, and I'll actually put it in the chat as well, there is a website that has all these resources, including the recordings of the prior two sessions of this web. But all that being said, let's meet Darlene. So Darlene, tell us a little bit about yourself.
Excellent. Well, hello everyone. I'm Darlene. Really happy to be here. Yeah. So when you asked me to share some photos, of course I had to share food because I'm a big foodie. So that's my main focus, but besides toxicology.
We all need extracurricular activities. Why not food?
Exactly. Yes.
All right. And Darlene, you're a Washington State Patrol toxicologist.
I am, yes.
What that means.
Yeah, so I've been with the Washington State Patrol since 2018. Time has flown. I have undergrad in from Oregon State University in chemistry, and then from there I went on and I got a master's degree in forensic science. But then I didn't know exactly what area I wanted to get into because there's so many disciplines. There's biology, which is DNA, trace analysis. Because I had a background in chemistry, I thought that I would be doing more drug chemistry, which would be testing the drugs themselves. But then I ended up getting an internship with the Office of the Chief Medical Examiner in New York City. And that one was, they were testing the blood, the tissues for the presence of drugs and alcohol. And I'm like, this is it.
You found your calling.
I did.
Awesome. All right. Well, tell us about the Washington State Patrol and how the toxicology lab fits in.
Yeah, so this is our organization chart. And so this is for the entire Washington State Patrol. And toxicology lab is in that purple section in the middle. We're part of the Forensic Laboratory Services Bureau. And we are actually separate from the crime lab and the impaired driving section. So we're all by ourselves. A really interesting historical little fact here that I learned is that we originally were a part of the University of Washington. Wow. And then moved over to the Washington State Patrol. I don't remember the exact date. It was probably the early 2000s, late 90s, somewhere around there. And so we have, so that believe that's probably one of the reasons why it's separate and not part of the crime lab division. But yeah.
Okay. And can you tell us a little bit about the division of labor? Like what separates what you do versus the crime lab versus the impaired driving section?
Yeah. So with the crime lab, that is so impaired driving, that's probably easiest. That's the breath testing. Crime lab is pretty much everybody else. So that's DNA, that's firearms, that's going to be material sciences, that's the drug chemistry, fingerprints, all of that goes through the crime lab division. Also on the pictures, we have two pictures. We have two locations. The one on the gray building is Seattle. That's where we've always been until, was it October of 2023, where we opened up the second building, which is the brown building in Federal Way. So yeah.
Well, we have a whole bunch of pictures here that look like they're all of the lab, including one of you in action. Will you walk us through what we're seeing?
Absolutely. Also, this whole thing is going to be very picture heavy. um, but yeah, so that was a picture of me. When we first opened up our lab in Federal Way, there were some news outlets that came to ask us what we were up to. And so at the time, I was working on a validation. And I am, you can't really see it, but I am pipetting out blood. And I remember the photographer was like, "Ooh, cool stuff." And so he took a picture of me. So I was posing a little bit. And then also there's pictures of our instrumentation. On the right, upper right is our headspace gas chromatographs, which I'm going to talk about in a little bit. That does all of our volatile testing. And then on the lower left is an old, very old GCMS. In fact, I think it even has a little label, GCMS number 12. We name our instruments numbers. There's number 3 and number 5. And
No pet name? You don't give them, like Dorothy or.
I've worked at previous jobs where we had named them real names, but this one we only had give them numbers. But and then also on the lower right, we have a picture of our Federal Way lab. Looks all fancy. It's very new, shiny and bright.
Well, then why don't you start by walking us through the process of what happens when you receive a sample?
Yes. Yeah. So I thought I would talk about just how it moves, case sample moves through our laboratory. And the very first thing is when it enters our laboratory. So it can come in many different ways. So it can come through the Postal Service, UPS, FedEx. And then it can also go through our Washington State Patrol campus mail, or it can be hand delivered. So on the right is a picture of a hand delivery where they'll actually bring the kits themselves with the request for analysis forms.
And is it strange to send biological samples through like the mail?
So no, that is a very common method. I used to work for a private laboratory, and that was the only way to get it through. So there was always FedEx or UPS showing up at our labs.
And it's fair to assume that you have to sign for those packages when you get them?
Yes.
Okay. And then you had mentioned the request for analysis.
Yeah. So every case sample will come with a request for analysis form that is filled out by the agency or usually the police officer, or because again, we not only do DUIs, we do also work for coroners and medical examiners. So there's a separate one for death investigations that they have to fill out. There's a separate one for drug facilitated sexual assaults and drug investigations. I have a picture here of our DUI and our DRE form.
Then if you could just tell us a little bit more about this form. It looks like this one's filled out a little bit.
Yeah, so this one is one that we filled out as just kind of like an example. The person's name is John Doe. But it'll have like their name, date of birth, and then the information of who sent it, the agency, who to send the results to, and then usually just the information regarding the case. And some of this is at their discretion. They can give us as much info or no info at all, but we have that option of writing down like what the history is or what's suspected. On the right side, we have what we fill out as a laboratory when it's received. We'll write what the ST number is, what the identification that we'll assign it to in our laboratory, and then the estimated amount that is present in the tube, and then any type of discrepancies. So like the property evidence custodian is the very first person. So they're the person that'll be signing off in the FedEx or that hand delivery. They're going to open it. They're going to take a photograph of that tube and transfer all of this information into our system. And so if they see any discrepancies, they're going to put that in the others or notes. They're going to note like the condition of the tube. And then the very lower part is like a chain of, oops, actually this one doesn't, there's more to it at the bottom, but there's like a little chain of custody signing where who has possession of it, who's bringing it into the lab and whatnot.
And so I notice on this example that it says other notes and it says first name on the tube's John. So it would be unusual that John would be on the tube. So they wrote that there. Is that a fair way to say it?
Yeah, so this is a common thing that we wanted to note on here is that um, a lot of the tubes that we get, so some of them are like labels from the hospital that are on the tube, but sometimes they're handwritten and not particularly well. And so we will look at there, and if there's any variation of spelling or a different birthday or even agency case number, we'll note it there.
So the next step in the process,
Yeah. Yeah, I skipped ahead just a little bit. So we call this accessioning. So this is the process where the property evidence custodian, and this is Bob, by the way. Bob has since retired. This is a very old photo, but he he was our property evidence custodian for many, many years. So he would get the case sample and he would so he's taking a photograph of the tube and that gets uploaded onto the system.
and is
And
that
so
the
his
tube right there? That right?
yes.
Okay, I just want to make sure.
Yeah. And then and he's going to do the whole process. So the whole process of accessioning is not just the photographing of the tubes. It's the opening it, entering it into our system, and then checking that information.
And you said entering it into the system. So in the last slide, you said that you gave the sample an ST number. Is
Yeah.
that how it's then entered into the system?
Yeah, so it's a really long, so we call it LIMS, and it's known as a Laboratory Information Management System. And that is just a really long name for a software. So every laboratory may use a different software. Us in particular, we use something called Justice Tracks, but that's what we use as our LIMS system. And that is what's going to assign it that unique case ID number, and that will be that ST number.
Great.
Yeah.
More pictures. Tell us what's going on here.
Yes. So this is one. So this is a slide. So a lot of these slides are old that we share at usually a lot of outreach with kids. And so we'll be like, these are all the type of samples we get. And, you know, so there are in this picture, there are maggots on the lower left. This is for death investigations,
Wow.
obviously. So we can get liver samples. We can get, which I think on the upper right of that one is stomach contents. And so, so we're getting all kinds of, not just DUI blood. So in this one, the only DUI sample in that picture is on the gray top tube on the upper left. And then usually red top or well, always with red top is usually death investigations. This may not just contain blood, it may contain urine, it may contain something known as a spleen squeeze, which is pretty gnarly. And then, or it could contain vitreous fluid, which is fluid from the eyeball. And so yeah, so these are all just like an example of what we can get in the lab.
So the next step in the process, extraction.
Yes.
Tell us about that.
Yeah, so this so once that whole process is done, it gets assigned to an analyst. And so as me as the analyst, when I'm assigned this case, I'm going to repeat that property evidence custodian's process. I'm going to double check we get about 16 to 18,000 cases a year. And so we double check everyone's work, or we're going to make sure that everything is spelled correctly and whatnot. But once it's time for testing, we don't actually just put the blood or the spleen squeeze into the instrument. I think the instrument would be very upset if we did that. So, so we have to do something known as an extraction process. And so that is where we are, and there's many different ways that we can go about it. So the one on the left is an example of a solid phase extraction. And so this involves tiny, mini little columns where we'll put the blood into, and then it goes through that white substance that you see at the bottom. Excuse me. The one on the right that's Katie Harris. She's now our lab manager for the Federal Way Laboratory, but she was once an analyst as well. And so she is doing a liquid extraction where everything is done in a test tube where you add a whole bunch of reagents and shake it up, and there's like a cool separation. Fascinating stuff that I love to talk about. But So all of this has to, so that we can in the end get an end product of this really nice, clear, clean sample that will go into the instrument.
Is there any possibility that these processes somehow affect the integrity of what's actually in the samples?
So with every single extraction, um, so um, so the one, I don't know which one of these in particular, but they usually are very specific onto what they're collecting, right? The one on the left, I know for solid phase, we do fentanyl with solid phase, we do opiates. There's a whole bunch of others, but like, so there is a very detailed standard operating procedure about
Um,
how to go about it. Like, so the reagents that get added have to be in a certain order. The timing that things need to spin is at a certain time. So there's like a very, and I think all of that is available on our website for every single test that we perform. But so yeah, so there's a very detailed list of things in the order that they need to go in.
so it's not like the Wild West where you as an analyst are just coming in and being like, oh, I feel like doing
Right.
this test today. It's like there's literally a line by line process you have to follow.
Yes. And then again, every single tube belongs to a case or a control sample. And so you can kind of see they are individually labeled, so we can keep track of them. Every analyst has their own method of organization and how they are going to keep all of those separate. So, like for instance, myself, every single time I am pouring in that sample of the case sample, I'll do things one at a time, right? I'm not going in there and, you know, it's a very, so I will take a little absorbent pad and I will open the case vial like that it came in individually, and then I will take a bit out and then I will put it in where it needs to go in. Then I'll seal that up and then move on to the next one. So yeah.
Well, then will you tell me about drug scope? What the
Yes.
heck is that? And what does that mean?
So this is something that is very so it is something that is done all throughout toxicology laboratories in the US, but this is something that's very specific for Washington State, and there's very detailed on how we go about it on our website. But pretty much a drug scope is like the extent of our testing, right? What type of instrumentation that we use, right? What type of drugs we're going to test for, and then like how we're going to report them, right? And so what's unique about Washington State and is that, and this only applies to DUI investigations.
Okay.
Um, so it doesn't apply to death investigation or even DREs as well. But we have a method in that when our initial testing will be volatile testing. And so if that ethanol value is above a 0.09, so up on the upper right hand side there, we'll stop the testing and we'll report it just as is with just we won't do any further drug testing.
Okay.
If it's less than, then we'll go on to cannabinoid testing. And that also has, like if it's greater than 7, we'll report that out. And then if all of that is either less than that or is negative, we will move on to a full drug screen, which involves time of flight. And so yeah.
So you mentioned drug screens. What's a drug screen?
Yes. So with drug screens, we have 3 major ones. And so this is all of the initial testing that we do. This includes volatile testing. This includes cannabinoid testing and then our time of flight. So the very initial one, of course, is our volatile testing. This one is unique. So volatile testing is unique compared to drug testing because we're doing both the screen and the confirm at the same time.
Okay.
Um, and so, whereas with our drug testing, there's going to be a specific drug screen using one method, and then we'll do a confirmation method, which I'll go more into detail later. But
Sure. But let's go back just a little. And so you do the screen to find out if the thing you are testing is present, and then you do the confirmation to find the quantity. Is that a fair way to put it?
so that's how it works with drug testing.
Okay.
So, like I said, with volatile testing, it's very unique in that we are getting a value for both tests. And so, because we're using the same instrumentation, which is headspace gas chromatography. So here is on the left-hand side, we have our instruments. We have 4 of them in the Federal Way Lab. 2 of them will have one type of column, which again, I'll talk about in just a second. And then the other 2 have another column, and both of them have different separation properties. And
Okay.
so we will take a sample, and the thing on the right is known as the auto diluter. That's going to draw up. So this is the one on the right is this extraction process.
Okay.
And so it's different. It's not solid phase. It's not liquid. This one, we are actually just taking a small amount of that blood and we're
Uh-huh.
diluting it down.
Okay.
Which I think I have a picture of it on the next
All right. Let's
slide.
go to the next one then.
Yes. Yeah. So on the left here, we have a picture of what it ends up looking like. So we use that auto diluter to draw up 200 microliters to be exact of blood, which is very small, so not a very large amount. And then it gets diluted down with a mixture of N-propanol, water, and salt. And then it gets capped with that cap right up top, real tight. And then on the right is how they are entered into the instrument, right? So there's this little claw that'll come, the claw. We'll grab one of the vials and then it'll put it into the instrument. And so this little visual in the middle is kind of talking about how it works. So what happens is the vial will get drawn down into the instrument and it will heat it and it'll pressurize it.
Okay.
And so it's using this this theory known as Henry's law.
Okay.
So that Henry's law states that if the temperature and the pressure is constant, then the concentration of that substance in the liquid will equal the concentration of what's in that airspace. So volatile samples, because volatile means that they will go from a liquid to a gas very easily, they will rise up from that blood into that airspace. They're also known as the headspace. And so it kind of shows you the bubbles coming up and going into that airspace. And so when the instrument is only going to sample that airspace, it's not going to draw blood into the instrument. And so, and then it goes into the column, which is this really long coil. It's like 30 feet long.
Maybe this
And
will be helpful.
yes. So it goes into the thing on the left where it go and I don't have a picture of it, but when you open that door, you just see this giant column. It's like this coil. And so what
The
happens
store, is
is,
that the one you're talking about?
oh, yes, right
Okay.
in there. And so that coil is going to have properties that will separate out um, the the different volatiles in that mixture. So the whole concept of chromatography is just separation from a mixture.
Uh-huh.
Um, and so like for instance, when we initially test it to see if it's positive, we'll get a value because once it's through the column, it's going to go into the detector. And the detector, which is a flame ionization detector, and that's how it's able to measure and identify it. And then from there, if it's positive, we'll do that whole process again. We'll go back to the auto pipetter, we'll drop a new one into a new vial, but then we'll put it into a different headspace, a headspace gas chromatograph that has a completely different column with different separation properties. And
Okay.
so that's why it's kind of unique from the drug where it's like it acts as both the screen and the confirm, and we'll get values for both of those instruments.
Okay. So if I can back up and ask a couple questions,
Yeah.
it sounds like it's the same process to get whether or not it's present and the actual quantity, but that you actually do 2 processes for each of those results. Is that right?
Yes.
Okay. And it's headspace because it's called headspace chromatography because literally this area is the area the machine is measuring,
Yes.
the literal headspace.
The space. Yes.
Okay. I think I got it. Not
Very
sure.
cool.
Well, let's move on. this looks like some kind of result. Will you explain this to
Yes. Yeah, so this is what we see once it is completed. Also, when you get a discovery and you get the data, this is what you'll see. And of course, it's like, what does that mean? So yeah, all those peaks are that separated volatile substances that we search for. So when we create that little vial of so this one is of a control that contains all of the volatile substances that we're looking for.
So I would think it'd
Um,
be strange for you to actually have this result.
right. So yeah. So in the vial is a mixture, right? It's going to be all mixed in there. But once it goes throughout that column, it gets separated, and then they'll come out one at a time. And so that first one is methanol, ethanol. We do isopropanol, acetone. And then the last one is that N-propanol, which is what we're diluting it with.
Okay.
And that is known as our internal standard. And so, and an internal standard has a lot of different, it's very valuable. So we are looking about so if it's there, it shows us that it is working properly because we're looking about how much is in there and underneath that peak area column. But it also is used to actually measure it. And so because we're not just putting in the case sample and putting in the instrument and being like, tell me what it is. We're also running a set of calibrators, standards, positive controls, negative controls. And so on there, below there, we have our compound name. That RT means retention time. Retention time means the time it took for it to go through that coil.
Okay.
The peak
That big
areas,
tube on the other picture.
yeah.
Okay.
And so, and the peak area is how much, pretty much its response, which is something we're looking at. And then it's great. It does the calculation and tells us how much is actually in there. And it does that by looking at that peak area, looking at that peak area of the N-propanol and comparing it to our standards.
So if I back up again just a little bit, this test, headspace gas chromatography, it can only be used for certain things. Is that because it's the volatile analysis as opposed to something else?
Yes, so this one, so Headspace is pretty much only capable of doing volatile substances. So we have it validated that we are only looking for these substances. We can see other things in there. Another real popular one is difluoroethane, which
Okay.
can be found in whipping cream canisters,
Okay.
air canisters. So that's another one that we usually will see. We'll see other inhalants. But we have our own method to look for those. But it is capable of seeing multiple different types of volatile substances.
This graph that's on the screen, I don't see these when I get a toxicology report and discovery. You said that this is part of the underlying data. How would I get this?
Yes. Yeah. So you get this if you ask for all of the case file. Also, and this is something that I always share with everyone, is that in the case file, you will get a copy of that request for analysis form, and then you'll get this raw data of the case sample itself, but it won't include any of the data for the calibrators, the positive and the negative controls. Those are separate. So, but you can find out what, even by calling your toxicologist and asking, we'll give you the batch number and what to specifically request. So.
Thanks. This looks like another instrument. What's this, Darlene?
I know there's so much to talk about. It's like, woo, moving on. So what's really nice is we use this for both screening and confirmation. So I'm only going to talk about this once. This is liquid chromatography tandem mass spectrometry. That is a huge mouthful, also known as LCMS-MS.
Okay.
And so this is what we use for our cannabinoid screens. We also use this for our cannabinoid confirmations. We use this for actually, right now, all of our, we are really moving toward using this primarily as our confirmation method. A lot of that, because historically everything has been done through gas chromatography mass spectrometry. And so the only difference, they have the same exact principles.
Okay.
but the only difference is gas. It uses gas to move the sample through. This one uses liquid. So those little bottles on top will have solvents like water, acetonitrile or methanol. The reason why we're moving more towards this is because with gas chromatography, we use helium as one of those gases. I don't know if anybody knows about the shortage with
Don't know
helium.
about the shortage, Darlene. Tell us about the shortage.
It's like they don't really sell helium balloons much anymore because it's like we have issues with getting some of these supplies.
I see. Okay.
So in the field, we are kind of trying to find other ways to do this without, gobbling up all these precious resources. um, but so anyways, and of course with LCMS, it uses water, which is great. We got plenty of that. And so it acts a lot like headspace gas chromatography in that it will take the sample in, but we have to do that whole lab extraction process where we do the liquid extraction or the solid phase extraction to get this nice clear little excuse me, substance that will go in there. The column is not this really long column coil. It's instead this really short little thing. It's tiny, but it's also packed real tight with silica and other little goodies in there that will act as that will separate the compounds in that mixture. I know this is really complicated, but that
Do I
little
need to know what silica are?
it's a substance, but what was it? There's so some of it's proprietary as well,
Okay.
what's in there. But its whole purpose is to separate out those THC from carboxy THC, from
I see.
methamphetamine to an amphetamine or whatever you're looking for.
So the
I know.
compound's constituent parts.
Yeah. So so again, this little cartoon is probably really hard to explain. Like, what is that?
It
So
looks
pretty much
intimidating.
it's so very simply, it takes the sample and it zaps it with electrons. EI, ESI, MALDI, those are all three. So there's not just one LCM SMS. There's multiple different types. We in our laboratory use EI, which it means electron ionization.
Okay.
So it zaps it with electrons. And so what happens is that drug. So I'm just going to pick on THC. We know what it looks like, right? We know
Yeah.
its structure. So when it gets hit with electrons, it will break apart into little pieces, but we know exactly how it's going to break apart.
Okay.
And so we pretty much tell the instrument to look for those pieces. And so what makes tandem mass spectrometry unique, and so pretty much means two mass specs side by side.
Which is the
So
zapping, right?
yes, so then it breaks apart again
Okay.
into even more smaller pieces. And then we tell the instrument to look for those specific pieces. And so that's pretty much the very easy.
Very, very simplified. What's the
It
benefit
goes,
of it being zapped twice or broken apart twice? What's the
yeah.
benefit for you as a toxicologist?
So for us, this is a really fantastic way to make sure that it is exactly what we say it is. So mass spectrometry, I took a whole class on it separately. That was a wild ride.
I'm not surprised. I am not surprised.
All of the, but I also took a course all by itself in just chromatography as well. But anyways, so yeah, it was the data on the next slide. I can't
It
remember.
sure is.
Yes. This will be easier to talk about it. So this is
Okay.
what we get. So these are essentially the little pieces. And so in order for us to say, and this is norfentanyl, not for it to say it is exactly what it is, we have a very, very strict criteria on what constitutes as a positive sample. And so on the upper left, the first two boxes are the two pieces of norfentanyl that we told to go find, right? So we need to see two peaks in both boxes. If we only see one, and then we don't call it positive, right?
And so
Um,
this isn't positive then, right?
so this is positive.
Okay,
We
and it's
see,
this two peaks here?
so it's the peak on the left and then the peak
What?
on the right. So it's both those two
Both of
boxes.
these together. Okay.
And then I know it looks like you see two peaks on that right hand. Those are both of those overlaid. It's the left and the right on top of each other. And
Okay.
so, not only do they both have to be there, they have to be at the correct ratios. And so if there is one more slightly than the other, then we're like, nope, that's not it.
Okay.
So, and then both of these boxes, because we're not just looking for norfentanyl, we're looking for fentanyl. And then on the right is our internal standard. So we use internal standard for every single test, not just the volatile, but every screen, every confirm. And so we have, and it acts as the same as that N-propanol, where we got to see it and at the right ratios, and then it also acts as what will quantitate it and give it a value.
And so that means, so these on the left, that's the sample, and then these ones with the D5 demarcation, that's the control? Is that
Oh, that's the internal standard. So that's
internal
something that we
standard?
will,
Okay.
yeah, so that's what we'll add to every single sample at the same amount. And so what we put in, we better see come back out. And then again, it uses it to measure it as well.
Okay. And remind me, why is it so important for there to be an internal standard with this test?
Yeah, so this is one where it's also very particular into what you choose to be an internal standard. It has to be something that is similar in structure to what you're looking for. And so norfentanyl. So the D, it's actually norfentanyl, but it's deuterated, so it's a heavier hydrogen. Like it's
Exciting.
it is very exciting. But so anyways, it's um sorry, I completely forgot. I was about to go on a tangent, but what was the question again?
Why is it so important for there to be an internal standard?
Yes. Yes. So yeah, so again, we add the same amount to every single sample, not just the case sample, but the calibrators, the controls, and then we better see the same amount in every sample. And then it's also very important because if it is there at the amount that we want it to be, it can use it to measure how much exactly is in there.
And again, you've used these other words, calibrators and controls.
Mhm.
Will you just run us through what that means and how that's important?
Yeah. So there's different types of controls. There's positive controls and negative controls. The positive controls are going to be, so in this case, fentanyl, norfentanyl, at very specific value. We'll usually have about three, like a low, medium, and a high.
Okay.
Excuse me. And they have to hit their targets. So like, if we're telling it to have 10 nanograms per milliliter of fentanyl, then we have like a range of plus or minus 20%, but it's got to be around 10. And then what was it? And then there's negative controls. So the negative controls are going to have no fentanyl or norfentanyl, but it's going to have internal standard. And then our calibrators, those are what is used to measure how much is in there. So those are going to be, and it's different depending on the test. If there's 5 calibrators, there's going to be 5 samples at a low end all the way to a high end of different concentrations with that same amount of internal standard. And so once we look at those peak areas, we look at the ratios between that and the internal standard and construct what's known as a calibration curve. And so that is what's used to compare to the unknown. So the unknown, this stuff really fascinates me. But so the unknown, like let's say this was the case sample, would take that ratio of what is in that unknown norfentanyl and fentanyl, compare it to what's in the internal standard, and then compare that to the calibration curve. And that's how it's able to quantify it.
So all of that's happening in this machine, or are those calculations you as a toxicologist make?
So it is calculated by the instrument. Some of it is some calculus as well.
So
uh,
really advanced math.
yes, and so we are also, once this comes out of the instrument, we are looking at all of those values. We're looking at that calibration curve, whether they're hitting their targets, and so forth.
And if we look at the peaks that are on the screen right now, how would you know if this sample there was something wrong with it, or if there was something wrong with the machine would you know just by looking at this, or is there some other way?
Yes, yes. So, like I said, there are a very long list of criteria that has to be met, and if none of them, or if one of them is out, then the whole batch is no good, and then we'll have to repeat the process. Um, I know. So in this presentation, I have examples of beautiful data. I didn't include anyone's where, because when you see bad data, you're like, that is bad data. Like, so sometimes those peaks are a little wonky. They're not very pretty and straight. We also look at those values. Are those values not hitting their targets? We're looking at those ratios. Are those ratios even in? So yeah, there's a bunch.
Okay. And again, would it be fair to say that if I wanted to get this picture for my case, I would ask for the case file? Would it be in there?
It would be in there.
Okay. Right. We've got more to do.
I know.
So what is LCMS time of flight?
Yes. So this one, I love it. So this is a relatively new technology that has really come up in the last decade since I've started in toxicology. In the old days, so like we used to use what's known as immunoassay, and we were using this even back in 2019. Immunoassay is a technique that where it's pretty much what you see in the stores, those little drug tests, right?
Oh, where something changes color?
Yes.
Okay.
And so again, it's not terribly exact. It's not specific. You could have a lot of cross reactivity, right? And again, the big thing is it's not very specific. So it'll tell you there is a benzodiazepine in there, but it won't tell you which one. But time of flight will tell you exactly what it is. And it is very, very, very sensitive. Sometimes those immunoassays are not very sensitive. So some of those, like lorazepam is usually given in pretty small doses. So what we see is very tiny amounts. And sometimes those immunoassays wouldn't pick it up. Whereas time of flight, it can pick up a whiff, you know.
Wow.
And
Okay.
so this one is absolutely fascinating. I did include a cartoon, but it is probably easier to just
Before
show
we get
you.
there, can I ask a question?
Yeah.
So I noticed that this is LCMS. So this is still liquid chromatography mass spectrometry.
Yes.
But because it's called time of flight, it's clearly something different than what we already discussed. Is it just an additional process that's added on to something else?
Yes, so it's an additional, so a lot of these instruments will be different instruments pieced together. So the last one was a LC-MS-MS, right? So there's two mass spectrometer. There's a liquid chromatography portion that includes that column and that separation. Then there's a mass spec, which is going to break it apart. And then there's the other MS, which is going to break it apart again. But in this one, there is going to be a separate column. There's going to be a separation. There's going to be one zap.
Does this help?
Yeah. Actually, so this one actually, and then if you go back real quick, you see the chimney. This is a picture of the chimney on its side. So I thought maybe it's probably easier to talk about it. So what's unique about time of flight is they got these chimneys. So there's two of them. There's one behind it, but this is my baby. This is time of flight number 2. And so once it goes through that whole process of separation and zapping, then literally going to shoot that thing up into the chimney, right? And I don't know what genius figured this out. It's absolutely insane. So it goes up and then it comes back down. It measures the time of flight, the time it took for it to go to the top and back to the bottom. And by doing so, it's able to measure its exact mass.
And I'm assuming, not knowing, that exact mass is more meaningful to you than it is to me.
Yes, so it's pretty much the entire, so we can compare that to a library, which then will tell us what it is. And so now the reason why this is a screening method and not a confirmation is that you will have a few drugs that have the same exact mass. So mass means weight. So it'll give us the exact weight to like the sixth or seventh decimal point. Like it's insane. Um, and so we will compare it to a library. But like for instance, morphine and hydromorphone have the same mass. So it'll tell us that it could be both. And so then that's why we have to go on to an actual confirmation method, which in this case we will do again, liquid chromatography, tandem mass spectrometry. So I don't have to go through that whole spiel again with
Oh, I don't think so. I don't think anybody wants that. Well, maybe you do.
Anyway.
And so just to circle back, it sounds like when you mention mass and it's meaningful to you in this testing, I guess what I think about is that mean like the numbers on the periodic table kind of
Yeah,
mass?
pretty
Is
much,
that what we're talking
yes.
about? Okay.
So I don't know if anybody remembers in chemistry, but like when you they give you a compound and you would, so it had carbon, hydrogen, oxygen, and you would add all the numbers in the periodic table, and that would be its exact mass. And that's exactly what that is. So it's counting up all the hydrogens and the oxygens and the carbons. And so, yeah, it's so what's if anybody was listening in on the last couple episodes, one of those big ones was those designer benzodiazepines, right? And so one of the big pushes for this was that when we were doing immunoassay, it would barely detect those designer benzodiazepines. We knew something was there because we were getting a response, but we were actually getting a negative value for benzodiazepines. And so, but we knew something because we're all nerds. We knew something was there. But the time of flight will say, oh no, it's flualprazolam or it's bromozolam, instead of telling us that there could be a benzo in there.
So if I go to this next slide, is it fair to say that even though this is this way, that this is the chimney part that we saw?
Yeah. So
Okay.
this is so a lot of these diagrams are very complicated. One of the greatest things that I love about being a forensic scientist is that I get to take all of this crazy stuff and translate it. It just goes up the chimney and down the chimney, you know, instead of, you know, it goes through an electron field generator and you know. So
All right.
So yeah, so then once they go through all of those processes, then it's, so again, morphine and hydromorphone have the same, I think venlafaxine and tramadol, like there's a few that have like the same exact uh, measure mass. So we will not report off of a drug screen alone. So it has to have a confirmation. And so then we either go through GCMS, but we're slowly kind of phasing that out in favor of LCMS or LCMS-MS. External laboratory is also an option. That's the one that we have a contract with is NMS laboratories in Pennsylvania. And so because of our drug scope, we don't test for a lot of drugs. One of those big ones is metrogene or kratom, right?
Okay.
We don't have a method for that, but NMS does. And so they have a lot of extra tests for some of the real unusual or because I'm sitting here thinking about some of the really real funky ones that we've never seen before.
All right. And so how often do you guys send something out to an external lab? That seems like that might not happen very often.
It doesn't happen very often. It is also always available upon request. But the reason why it doesn't happen very much is it is very expensive. So we do actually have currently a contract with them. They are doing our death investigations, most of them. And a lot of that has to do with our backlog and the turnaround time. We still are doing death investigations. But there's a whole thing about what stays in house and then what goes to NMS. But in terms of DUIs, it's not a common thing.
Let's talk about data review.
And that's Andrew, and he is still in the Seattle laboratory. He posed for so again, anytime they come out of this instrument, they have to go through a review process. So a lot of the things is, you hear a lot that these tests take a really long time. We have a very long, so not only so usually it takes a good afternoon to do an extraction. It'll go overnight, the instrument, to run all those samples. But then the next day, we have to go through all of that data one by one and review it. And then once we do that, it goes through a second review. So either another analyst or someone in management will come in and review that data again. So you might have heard of the term peer review. So that's when, so that's us kind of coming in again and looking at, so there's a lot of bottlenecks in review process of how, because we got a lot of eyes on these things to make sure that everything we don't miss anything.
Okay, I have some more things here. What are these?
Yeah, so I included data of Headspace and LCMS-MS, but I didn't include TOF, but this is TOF data. Yeah, so this is time of flight. And so, and again, there is that LCMS portion. So you're going to see those peaks. So this one I have morphine and methamphetamine. But then we get the extra added bonus where we get to see the pieces. Because remember, the MS part's breaking it apart. It's the little lines on the lower right. And so this is it's actually very hard to get a good copy of this online, but they have little boxes and it'll tell you the exact ratios in little colored boxes. We see this on the screen, which is why a lot of data review will happen on the screen itself. But it'll tell you it has to be at these exact ratios. And if they're not, then we won't call it. So in this one, this is perfect data. We got a perfect, beautiful peak. And then those little lines are fitting perfectly in the little boxes.
Okay. All right. So it sounds like maybe we're in a position to review the process. Will you just walk us through what the steps are in the process?
Yeah, absolutely. So again, it all begins with that property evidence custodian, it coming in, it's accessioned. We'll go through that alcohol and drug screen. And then and then those confirmation tests, which is going to be, for like carboxy or whatever we find in the time of flight. And then finally, it'll go through a final report. And then you'll probably hear another term, primary analyst. So me as an analyst, I'll get assigned a certain number of cases a month. And then, so when I get those, once all the data is complete, I'm going to get a copy of all the data as a whole, and I'm going to go and review the whole thing before I write that report. And then once I'm finally finished writing it, it goes through another review process. And so you'll see two signatures on a report. So there's going to be my signature, which is going to be, the primary analyst. And then on the right is going to be the technical reviewer, which will be someone in management.
Then we have another example of a report.
Yes.
And I wanted to highlight this part because I thought it might be useful for us to talk about this little plus or minus.
Yes.
And what this means. And the next slide is going to hurt my eyes, but I'm going to put it up anyway.
And I know I'm
ouch, that hurt. That hurt.
And I'm sorry. I meant for it to hurt. I'm sorry.
Okay. So, you're just trying to prove you're better than us. Huh?
So when you see that plus or minus, you'll see we can go back real quick and look at all that verbiage. There's a lot of verbiage. So you've got the value 0.13. But then you got the plus or minus 0.01, and then you've got the K equals 3, then you got the 99.7%, right? So how this works, this is known as the measurement uncertainty. Now we go back to the next slide.
Okay.
So
The one that hurts my eyes.
yes, so the how this is done is our quality assurance department and also our state toxicologist, they actually do an absolutely huge statistical equation. And on our website, we break it down how it's done. But it's going to, so measurement uncertainty, a very easier way to say is the variance of a measurement. And so the thing is that no measurement is exact, right? I had many years ago, someone told me this weird analogy, and I don't know why it stuck with me. I don't even know if it's a good analogy, but someone told me that if you take a dartboard and you set up some sort of machine to throw a dart and hit the target every single time, right? And you tell it to hit the bullseye every single time. But if you go on there and you actually measure the actual where it hit, it's never going to be exact spot on. There's always going to be some variance.
Sure.
And so, and we're talking down to like very small decimal points, right? And so, and a lot of that could be due to the environment, how it's set up. So in particular, in terms of toxicology, it has to do with our pipettes that we use. It has to do with our certified reference material that we use. Again, there's a number. So every little U is a different, and again, online, it tells you what all those mean.
Okay.
But the big thing is here is you see that UC equals, blah, 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 and the first one is that UR. So UR, the equation below that is just what that in itself is an equation.
It makes my head swim.
Yeah, so it is absolutely insane. And so the whole purpose of it is that, so this is actually the measurement uncertainty calculation for alcohol, for ethanol.
Okay.
And so they came up
it
with
really
a value.
does coincide with this then.
So we're not even to the 0.01 yet.
Okay. Okay.
So they did that whole calculation to come up with the value 0.0272. And it's like, okay, so I think I have it on the next slide.
Next one.
Yes. So where does that 99.7 come from? So the best way I can describe it is that we, if thinking about the bell curve, right? And so if you take the bell curve and in the middle, you have your mean. If you go out 3 standard deviations of it, you are that 99.7% of it will cover that. It'll cover that whole area, right? And so, that's where.
Can I back up and ask some questions?
Oh yeah.
So this is the mean?
Yeah, and so
each one of these is a standard deviation.
Yeah, going in both directions.
Okay.
So I'm trying to like translate it because it goes way out there. So in terms of like ethanol testing, you can think of the middle part as that measurement, right?
Okay.
The 0.13, right?
Okay.
And so then the thing is that that K equals 3 is about that 3 standard deviations, right? Okay. That 99.7. So if you multiply 3 by that 0.0272, you get roughly about 8.5%.
Okay.
That number is then multiplied by the 0.13, and that's how you get the plus or minus 0.01. Yeehaw.
Sure, whatever you say. I'm just going to nod and smile now.
So another way to look at it too is that if you were to perform this 1,000 times, 997 times, it will be within that area of that. And so So that's so how we will say it is that it is the true value of that ethanol result is going to be somewhere within that range. So from 0.12 to 0.14.
And are there like industry standards for what a measurement uncertainty should or shouldn't be?
Yes. So we have accreditations, and with measurement uncertainty, it is a very specific, yes, it is under ISO 17025.
What on earth is ISO 17025?
Yeah, so ISO is the international standards organization, and it doesn't just include forensic science, it includes every industry you could possibly think of. 17025 is specific for forensic laboratories, and it has been adopted by ANAB, who we are accredited by.
And so
And
that's
so,
these folks.
yes, so we are accredited by the American Board of Forensic Toxicology, ABFT, and ANAB. There are a lot of accrediting people out there, and they all
Okay.
start with A.
That
So
feels unfortunate.
yes, but these are the two that we abide. Like they ANAB will come to our laboratory every year or every other year, and will evaluate us to make sure that we are following all the guidelines. I am a ANAB technical assessor, and
Yeah.
so
You get to go
because
inspect other people's labs.
I do. I love it because I'm nosy. And also, I just love seeing other labs and seeing how they work and
Right.
talking toxicology. So, so yeah, I only started in 2021. And lately I've only been doing, and this is not, this is kind of by chance, but I've been only doing medical examiners lately. So far I've been to quite a few places and it's been fascinating, but yeah.
And I would suspect there's a whole bunch of stuff on your website about accreditation too. If,
Yes.
if someone were inclined to do a deeper dive into this type of thing.
Yeah. And then also, especially with me, like I always encourage everyone to call your toxicologist. We will make ourselves available. We will love to talk to you about, the case. All that stuff I talked about, you could go over it with the specific case. So yeah, it's I do, and I do it a lot and I love it. So
Well, we're so grateful for you. And so we'd just like to thank you for taking the time to do this web series and for presenting all this information to us. We
absolutely.
couldn't be more grateful. So thank you so much, Darlene.
Oh no, I love it. So thank you.
And everyone, we want to thank you for joining us as well. Here's the activity ID if for some reason you need to report this yourself. There's also the website on the bottom and in the chat where you can find the resources and the recordings. We will post the recording of this particular part of the series probably in about a week. It just takes us a little bit of time to make sure everything's in its proper working order. But we do very much appreciate you joining us and hope you have a great rest of your day. Bye, folks.